Hello and welcome. In this playlist of a Spring Framework 0 to Hero on my channel, we have learnt a few basic yet important concepts on Spring Framework till now. Now, let's take things one notch up by learning a few powerful techniques provided by the Spring Framework, which is aspect-oriented programming. But before we start learning the intricacies of AOP, let's understand what is an aspect. An aspect is a simple piece of code which you want to be executed by the Spring Framework whenever you call some specific methods inside your application. Any application code consists of two types. One category falls under the business logic and the other one falls under the category of non-functional requirements. Examples of non-functional requirements could be logging, security, auditing, etc. Such code related to non-functional requirements could be written along with the actual business logic code, but it becomes a mess as the code base grows. So, instead of plumbing the code related to auditing, logging and security into our actual business logic methods, we can maintain them in a separate place with the help of an aspect. And we can configure the Spring framework which is smart enough to execute the logic which we mentioned inside the aspect. With this approach, we separate out the business logic code and the code related to non-functional requirements. It makes our code base more maintainable. Imagine a scenario where we have implemented logging and security inside all of our methods in the application. Let's say in 1,000 or hundreds of methods. What happens if there is a requirement change with respect to the non-functional requirements tomorrow? We will have to change all the code sections related to non-functional requirements in all the places. This does not seem correct, right? Moreover, it would be a cumbersome task to do so. So, with the help of AOP, we can build applications by separating the cross-cutting concerns, also known as the non-functional requirements, totally separate from the business logic. The way to do this is to build the non-functional requirement logic in a separate place with the help of aspects and configure those aspects to be executed on the basis of business requirements. So, even if there is a scenario where you have to change how you handle the non-functional requirements, the change will be in a single place and that will get reflected to all the methods present inside your application. This is a major advantage of using AOP. So you may be thinking, hold on a second, how is it any different from writing these aspects in some file and then invoking them by creating their object, right? We have been doing it all the time in the past and it was being done in the spirit of clean and modular code, correct? This AOP thing does not seem any different or special. Well, guess what? Not really. This is how AOP is different. This aspect-oriented programming dynamically injects the logic present inside an aspect whenever a particular method is executing inside your application. So you don't have to call the logic present inside the aspect manually. So that way, this is always pluggable into your application whenever you want. Just supply the configuration and you should be good to go. I bet by now you are finding all this quite useful and impressive. Here is what is more impressive. AOP is a module inside the Spring Core framework and all your configurations and housekeeping are taken care of by this module. You see, there is one more reason to love the Spring framework, right? Well, AOP is a very vast topic. However, I will be covering all the required details to set you up for success with using this. But if you still want to refer to some reference document, you can visit this link. Let me conclude this section by saying this. I cannot emphasize enough how important it is to understand the AOP concepts for a Spring developer. Spring itself uses this feature quite often in most of the other Spring projects such as Spring Security, Spring Data JPA, etc. Without knowing AOP, you could feel clueless about what's happening inside your application. This general sense of cluelessness arises due to the nature of abstract configurations of AOP and lack of typical Java method invocation. Java method invocations are intuitive to navigate and debug. Configurations, on the other hand, appear mysterious if you don't understand them quite well. So with this, I am assuming you got an initial sense of what is an aspect-oriented programming, and even if you're not clear about the aspects of AOP by now, please don't worry, all your questions will be clarified by the time you finish this video. And that's my promise. With that in mind, now it's time to start the next section and learn about a few very important and interesting theoretical concepts of AOP in the Spring framework. Now let's learn about some very important theoretical concepts related to AOP. Even though the theory could be boring at times, however, please trust me on this, it's much needed to build a solid foundation on the rather complex subject of AOP in the Spring framework. And frankly, this theory is not that boring, so let's get started. In order to understand the AOP in the best manner possible, you need to truly understand the what, when, and which. What is the code block which you want to be executed when something happens? Aspect is the jargon for this what. A real-world example of aspect could be a code block which prints log statements. Which is the code block or the method which you want to probe on. Saying it simply, which tells around the method which you want to intercept for some event. Point cut is the jargon for this which. A real-world example of point cut could be a method which, for example, is calculating interest on a loan amount. Any method you want to be intercepted by the Spring AOP is a point cut. When is the time during the flow of the method when you want the aspect to be executed. Advice is the jargon for this when. A real-world example could be before the method invocation or after a method invocation. So to repeat it one more time, point cut is any code block in your application which you want to be intercepted or probed. Aspect is the code which is typically your non-functional requirement related which you want to get executed. And advice is a time snapshot during the execution of the point cut when you want the aspect to be executed. In case you are finding it confusing, trust me on this. I have more than 10 years of hands-on experience with the Spring framework and I still find this jargon somewhat non-intuitive. So don't worry, very soon in this video we are going to see some code demo for these concepts and these concepts will become quite clear by then. Now let's learn about the three main type of advice. First one is before, second one is after, and the third one is around. After also has two subtypes. It's called as after throwing and after returning. So let's have a quick example of all of these three advices so we understand those in somewhat better manner. An example of before advice could be this. Before a method is called, the logging aspect may write a message to a log file indicating the method being executed. An example of after advice could be a security related task. After a successful login attempt, the security aspect might record the successful login in an audit file, and in case of a non-successful login attempt, the system could record the reason for failure in an audit file. An example of the around advice could be this. An aspect could handle a database transactions. Before a data update method, ensure everything goes smoothly and commit the changes or rollback if there is an error. I know you guys are eager to start coding to make use of the Spring AOP as soon as possible. I am equally eager to teach you the same. With that in mind, let's complete this last theoretical concept called as weaving. So, weaving is the general process of integrating aspects into the existing code. Dynamic interception of method calls is done by the proxy object creation, and weaving creates proxy objects that stand in for the actual target objects. These proxy objects intercept method calls and perform additional actions defined in the aspects before or after delegating the call to the real object. And when you invoke a method inside a bean, Spring creates a proxy object for that bean, and instead of making use of the reference for the bean itself, it invokes the reference for the proxy object. You might be thinking, this is totally confusing, right? Well, I get your sentiment. You might be finding it somewhat confusing to understand. So, with that in mind, I have planned for a quick ELI 5 for this concept of weaving. So, let's get started. Imagine you are a chef in a busy restaurant kitchen. You have different stations where you prepare food. One for cutting veggies, one for grilling meat, and so on. Now, let's say restaurant owner wants all the dishes leaving the kitchen to have a special garnish. Let's say a sprinkle of magic seasoning. But adding the seasoning to every dish individually would take a lot of time and effort, slowing down the kitchen, right? So here is how weaving using the proxy objects in AOP could help. Think of each station in the kitchen as different parts of your code, like functions or methods that do specific tasks. The special seasoning is like the extra functionality you want to add to every dish. In coding terms, it could be something like logging or security checks. Seasoning is basically your non-functional requirement. For the proxy chef, imagine a helper chef who stands at the pass and sprinkles the magic seasoning on every dish as it leaves the kitchen. This helper chef is your proxy object. It's not the main chef or the actual code in your class, rather it's there to add something extra to each dish without you having to do it yourself. So weaving is what the proxy chef does. It goes around adding the magic seasoning to every dish that comes out of the kitchen. In coding, it's like injecting the extra functionality in your code without changing the original code itself. In summary, AOP is like a set of instructions for the proxy chef. It tells them exactly when and where to add the magic seasoning. It helps them know which dishes need the seasoning and how to add it consistently. I hope this example should have cleared most of your doubts by now, and if you found this example to be simple, easy to understand, yet very useful, please smash that like button. It helps my channel with the YouTube algorithm. So with this in mind, let's get our hands dirty and write some code showcasing the magic of AOP in the Spring framework. Alright, so here we are in the IDE and we have a project which has been already set up. The idea is that we have a couple of packages, for example model, config, runner and service. So let's check out what exactly we have in the model. We have two classes and these are tagged as a component. So we want these classes to be managed by the Spring as a bean, right? So this one is called as chef and it has a method which prints chef is cooking. The other one is server. It again has a method called as serve and it's a component. It prints a message called as server is serving. Now coming to the project config, this is just a config class. So I have tagged this as configuration and the component is scan is that it should be able to scan the packages for the model and for the service. Next, let's have a look in the restaurant service. So in the restaurant service, I have given a logger because I want to print something in the log file, and I have kept two dependencies here. So the first one is chef, the other one is the server, and auto wiring has been done using the constructor injection. So now coming to the methods in this service, we have three methods. One is cook food, the second one is the serve food, and the third one is generate the bill, right? So in the cook food, it is going to accept is food order placed boolean parameter, and if it's true then chef will cook, else it will print the log message no food order placed, cannot cook. And in the serve food, we again have a boolean parameter called as is food prepared. So if it's prepared, server will serve it, else it will throw a message and it will read like food not prepared, cannot serve. And in the generate bill, it is going to accept an amount, and if the amount is not empty, it's going to return a string which says you gotta pay an amount of certain amount, else it will throw a runtime exception. And other than that, what we can see is I have placed lots of log messages. So here I'm finding out what is the current time, what is the finish time, and the first log message is like this particular method has started with its execution. Then here the execution has ended, and after finding the finishing time, we are finding the duration which has elapsed between the start and the finish time, and the same is getting printed on the console in the log. And the same kind of thing is being done for this particular method itself. In the generate bill, what we have is if it's null, then we are throwing a runtime exception. So that's about what we have implemented till now, and just to save some time, I had kind of coded it in advance, and currently I'm just giving you a code walkthrough. So we will be building on top of it. Now how exactly this program is being executed? We have a runner class, and what it's doing is it's creating a context from the project config, and from the context it's fetching the bean for the restaurant service, and then it's invoking methods such as cook food, serve food, and then printing the generate bill outcome. Let's run this once and see what is the outcome like. So nothing fancy here, like we are printing all the logs, then we are printing the details with respect to how much time was taken for executing a method, and so on and so forth. And finally the message is getting printed like chef is cooking, server is serving, and you gotta pay an amount of so and so amount. So see, what is happening here is that in this example, if you take a closer look, the only business logic which has been implemented is chef.cook. Certainly we are checking like what is the boolean parameter, but if you take a closer look, this is the only business logic which has been implemented. Everything else is kind of not something which is related to the business logic which is getting implemented. So these things are not good. They are kind of cluttering this code block. They shouldn't be here. And let's say if something changes in future in the approach, of how we are going to calculate the time executed for running a given method, then we will have to change all of this in all the places where it has been implemented, right? And that is not good. That is what we discussed in the theory section. So what is the way in which we can achieve the aspect oriented part of the implementation? Now let's create a package. Let's call this as aspect. And the first feature that I want to create is that I want to check the status of the food, whether it has been prepared or it has not been prepared, and based on that I want to do certain actions. So let's create the class for this, and let's call this as food status check aspect. In order for this to be identified as an aspect, we need to annotate this with this annotation, and later on we want to have this annotated as a component as well. What we want is this to be managed by the Spring framework, and we will have to mark this as a bean for the same. So this has been marked as a component now. And the first thing that we do is we will first create the logger object so that we could log a few things. Let's call this as logger, and this is logger dot get logger, and the name is food status check aspect dot class dot get name. So we have created the logger object, and now first I want to check if the food order has been placed. So let's create a method, and it will return a void. I will name this method as check if food order placed, and it will take a boolean parameter is food order placed. So if the food order is not placed, what I'll do is I will log something, and maybe the message could be food order hasn't been placed, so I want cook. So once we have done this, let's exit out of the execution. Now we have given the implementation. So in order to guide the Spring AOP that where exactly I want this particular piece of code to be executed, I'll have to give two things. First is I will have to give it some advice. So advice is I want to do it before execution of a method, but I have not told Spring AOP that which method exactly is this, right? So in order to do so, we will have to define something called as a point cut. So what exactly is a point cut? Let's revisit the concept one more time. So imagine that there is some sort of code execution which is happening. So maybe let's go to the service class, which is this one. So imagine that we have started executing the restaurant service, and in this one I am currently here, and after some time the execution will be at line number 26. So each and every line, each and every instruction in the code is a point, right? So everything is a point. Essentially when you put a debug point or a break point, that's also a point, right? So if you imagine the execution flow as a straight line, all these things are certain points. So point cut is essentially a particular spot during the execution of the program, and the expression that we design, which will be used along with the advice, that is going to be the point cut expression, which will be telling the Spring AOP framework that hey, let's say for this particular given method, when you are here at line number 26 and then you are about to go to line number 27 and begin the execution for this particular method, you are supposed to do a few things. So this is what we have. We have the advice. So before you start with certain things for a certain particular point in the code execution flow, you have to do this, right? So now let's understand a few things about the concept of point cut. So how exactly are we going to create the expression? So for understanding the expression in the point cut, we should first have a good understanding of what is a point cut designators. So there are quite a few point cut designators, let's call those as BCDs, and the main ones are execution, within and arg. So execution signifies that whatever regex is being provided, that will identify a method, and when that regular expression is being used with execution, it means that whatever advice I have created, that should be evaluated during the execution of that method. So let's understand what exactly is the regular expression telling us. So the first thing is the return type, and when we have a star, it means our method could return anything. It could be any return type, and this is basically the package. So inside the codes.shandilya.service, this is the package name, and it could be any class inside the package, and then it could be any method inside the any class, and this thing signifies the number of arguments. So essentially, if we look at the entire regular expression, what it's signifying is that any method inside any class inside this particular package, which is codes.shandilya.service, and any number of arguments for that method. So when such method is executed, then I have to execute the logic that I have written in the advice. Don't worry, it may be sounding sort of complicated, but pretty soon we are going to have a code example that will simplify all these things. The next thing is within. It's very similar to execution. The only difference is that when we say within, what it signifies that any class, any method that is inside this particular package. So basically all the packages and all the classes and all the methods inside those classes, everything is kind of covered with this kind of designator, which is the within. The next one is the args. So it is used to specify a method. So when we say that args is food order placed, what it means is that there is a parameter, this parameter, and other than this parameter, it could have any number of parameters. So essentially, find a method which is going to accept one parameter of this type, and after that we have any number of parameters. The type would be clear when we explain the code, when we write the code rather, because the type binding happens when we have the method signature. So let's wait for some time, we'll implement this and it will be much more clear. So one more important thing about these designators is they could be combined together using the Boolean operations. For example, and, or not. So basically you could combine more than one point cut designators, and they should be able to uniquely identify the methods where you want to apply some sort of aspect. The example could be this. So what it means is you go and check for the execution of this particular these particular methods, and out of those methods accept only those who are honoring this criteria. Now let's get back to the code and see what we have. So you see, we have provided the parameter for this method and the type is Boolean. Now let's write the point cut expression for the same. So the first is going to be execution. The first one is a star, means it could be of any return type. Then let's provide the package name and any class inside this package and any method inside either of these classes, and then it could accept any number of parameters. So let's close this here, the first execution, and now let's combine this with the arguments parameter. For the arguments we have args, and I will pass is food order placed, and after this it could accept any number of parameters. So we have completed the point cut expression for this advice. Now you may be having a question that how exactly these types are resolved. Is it so that I need to pass the same method variable name that I have in the service? So here we have this is food order placed. So does it mean that we need to have the same name? Well, that is not the case. Then you may wonder that how exactly this is getting resolved. So let's have a quick look on that as well. So how arguments are mapped? Spring AOP relies on the argument positioning and argument type for mapping. So let's go back to the code. Here we have only one argument, that is food order placed, and then we are saying that there should be this argument which is of this type. Other than that, we could have any number of arguments in the methods. So now let's go back to the service. So in this method I have this parameter which is a Boolean type. So that is the type that is getting masked, and after that it could have any number of parameters. So here I don't have any other parameter, so this method is qualified for the aspect to be applied. Now coming to this method, here what we have is a string. It does not have a boolean, so in that case that aspect won't be applied to this method. Alright, I hope it makes sense now. So you may be wondering, well, what happens if I have, let's say, more than one boolean type here. So let's say we have this regex expression, which is this package, and inside this package the idea is to intercept a method which is having two boolean types, and other than that it could have any number of parameters. And let's assume that in the service class we have this method signature where we have boolean is food order placed and other boolean is urgent, and other than that let's say we have n number of other parameters. Let's place those quickly. So the mapping will be done on the basis of relative positioning. So the first boolean here is food order placed. So the position of this one is the first one, and the next boolean is this one. So the next boolean would be this one. So on the basis of the relative positioning, it will be mapped, and this is how arguments are mapped in the context of Spring AOP framework. So you don't need to pass the exact variable name. Now let's come back to the code, and here we have executed the before aspect. So let's do one thing, let's try to run it and see how the outcome is coming like. Let's go to the service, and in this service let's get rid of all the logs that we are printing. Now let's call chef.cook, and let's go to the config. So we need to do certain changes in the configuration file in order for Spring to identify the aspects that we have created just now. The first change is that I need to include the base package for the component scan, and that would be codes.shandilya.aspect. So basically this package we created, and we want this to be included in the component scan. The next change is that I want to have this annotation, that is enable aspect j auto proxy. So this is going to tell the Spring framework that we are trying to make use of the aspect oriented programming. Please do make use of the aspects that we have created. So now let's have a look inside the runner class. Let's run this and see what is the outcome like. So what we are getting is this particular output. Reason is that we have passed true here, but in the aspect that we have created, we are going to print this log only if this is false. So let's try to pass false over here and see what is the output. So let's run it one more time. So you see we are printing the log now. The log is food order has not been placed, so I won't cook. So let's do a dry run now and see what is happening over here. So let's just start with project config. In the project config, I have added a new package. So whatever aspect I'm going to create, that is now going to be the part of component scan, and I have also asked Spring framework to enable the aspect j auto proxy, which is a guideline for the Spring framework to make use of AOP related features. And in the restaurant service, I have removed all the logs. I have just placed the required business logic, which is chef.cook, and I have also created an aspect, and in this one I have provided this advice. So this advice is going to execute for this particular regular expression combined with this particular argument type. Now that we have seen how can we implement a before advice, now let's go ahead and create a few other advices. So in order to demonstrate the creation of other advices, I will create a different aspect, and let me name this as logging aspect. Let's start by annotating this with the aspect annotation. The next annotation would be the component, and let's have a logger here. So we have a logger. Let's also make this as private and final, and it could be initialized as logger.getLogger, logger aspect.class.getName, and now we have the logger object. So as I told earlier in the theory section, that the after advice has two types. One is after throwing, other is after returning. Sure, we have an after advice as well, which is the mixture of both of these two, but for this demonstration, let's have the example of after throwing and after returning. So here is the method that I'm going to implement. Idea is that there is a method which is going to return a void, and it's called as log exception. It will accept a join point. Let's call this as join point, and an exception object. Now let's use the logger to log this. So what we can say is join point dot get signature exception occurred due to, and then exception dot get message. So before we implement the after throwing annotation and put in the value for the regex for the execution and all, let's have a quick look around what exactly is a join point. So join point is something which is going to give us two information. One is the location. So it pinpoints a particular event in the program flow. And the second thing is it holds some information details, and the details are regarding the method signature and the arguments. And in order to understand this, let's write the after throwing annotation. It will accept a value, and the value is going to be the regular expression that we discussed in the previous example while creating the before advice. And let's have a star, which means that we are going to accept any kind of return type, and the package is codes.shandilya.service, and in this we are going to accept any class and any method. We can also pass and another attribute, and this is called as throwing. So let's name this as ex, as in the exception. So what throwing does is it signifies that this thing is going to throw an exception, and using this handle we can capture it and we can make use of that exception. So either you could handle the exception, or you could just probably log it or do whatever you want. So what exactly is join point in this case? So in order to understand the join point, let's go to the service class. In the restaurant service, when that execution regex is executed, it will try to execute this method here. So when we say join point, the join point is having a certain information. The first information regarding the location is that we are at this particular method, and the other information regarding the details is like it has the method signature and other things with respect to what are the arguments that this method has. Now let's go back to the logging aspect class. So here the way in which we are making use of the join point is we are extracting the method signature. So we are going to capture the exception and make use of that exception to fetch the message details, and then from the join point we are fetching the signature, and we are using these two information to print this log statement. Now let's run our code and see how it's getting printed. Let's go to runner and let's make this as true. So why did we make this as true? For that we will have to quickly check the aspect here. So once we are in this particular block, we were exiting from the code execution, and we don't want that because we want to test out the further things, right? So in order to do so, I have made this as true, and now we want to check the use case wherein we are throwing something. So when do we throw this exception? Well, we throw this exception when this amount is empty. So let's do the same. Let's pass an empty string here, and then the expectation is that this particular log should be printed. Now let's go to the runner and run it. So here is the outcome. First is chef is cooking, so that is from this one, and now from this one we have this info message, that is this is the code signature generate bill, exception occurred due to no bill amount present, and this is what we had written in the logging aspect as well. Exception occurred due to exception dot get message, and when you check the restaurant service, this is the exception which we are throwing, no bill amount present. So that is the message that we are throwing. So when we run this, it's going to invoke this particular method, and when this method is going to execute, at this point of time this aspect comes into action. And what does this aspect do is it says that after you intercept this method, and if there is an event wherein this method ends up into throwing an exception. You capture that exception, and from that exception you fetch the message and make use of that message to print this information in the log. So this is how this thing is getting executed. Now let's implement the other variation of the after, which is after returning. So after throwing was used in the case where the method was throwing an exception and then exiting. But in the case of after returning, this advice is executed whenever your method exits in a normal way after returning some value. So in order to save some time, we can copy this entire thing and just paste it here. There is one difference, however, that instead of throwing, what we need to pass is returning, and maybe call this as return value. And of course we will have to have some method, so let's call this as public void and log return. We will pass a join point and then we will pass the return value, and what we want to do is logger.log join point dot get signature plus method returned successfully with value and then the return value. So let's go to the restaurant service. So based on the join point execution, all these methods will be intercepted, and whatever is being returned, that will be captured and made use of in the log message. Let's go to runner, change a few things. So what we want is that this particular method should not fault out and it should return something. So let's place some value. So it will generate a bill for this amount, and now let's run this one, and here is the output. So this is being printed by this particular method call, that chef is cooking, and then the first method is getting intercepted, that is cook food, and method returned successfully with value null because we are not returning anything. Then the third method is intercepted, that is generate bill, and method returned successfully with value. You gotta pay an amount of so and so. So let's try one thing. Probably let's call the other method as well, which is restaurant.service, and serve food, mark this as true, and this time what we should see is 3 logger messages. So let me clear this one and let me run this one. So indeed we are seeing 3 messages. First is returned successfully with value null, serve food returned successfully with value null, and generate bill returned successfully with value 1.4. So that's about the concept of after returning, and hence we completed the learning for the after advice. So you may be wondering what happens in after. Well, that you could try as an exercise, but I'll just help you with some information here. When you use after advice, in that case that will be executed in both the cases, regardless of the fact that your method is exiting in a normal manner or maybe it's exiting because due to some exception. So that's about the after advice. The other advice that we have is the around advice, and it's also at times called as the most powerful advice. What is the reason? Well, it provides some sort of better flexibility with the help of code execution. So in order to implement the around advice, let's start with implementing the method. So let's call this as public void log time, and we have something which is called as proceeding join point. What this is, I'll come to it in a moment. So here is what we are going to develop for this advice. First we start by logging a message that method execution is starting, then we capture the start time, and then we capture the end time once the method execution has ended, and finally we capture the elapsed time and then print the same, and in the last we can also print method execution finished. So let's get going and do the same. So we start by logger.info pjp.get signature plus method execution started. Second is we want to capture the start time So let's call this as instant dot now. Let's have this pjp dot proceed. I'll explain all these things in more details. Please be with me for some time. Instant end time. Let's capture the end time. So instant dot now and logger dot info time elapsed duration dot between start time end time 2 milliseconds and logger dot info pjp dot get signature method execution finished. So proceed is going to throw exception, so let's add this in the method signature, and let's add the regex expression for the around advice. So it's going to be execution, and this is for any return type. This is my package, and for any class, any method inside this package. So this is what we have. So here we are seeing a few new concepts. First thing is around. So let's talk about it briefly. So the first advice that we discussed was before. So let's say if this is the method, then before is called here before the execution of this method. And the second advice that we discussed was the after. So let's say if this is the method for which the advice is getting executed, then that advice will be executed here after this method has been executed. Now when we talk about the around, it executes in both ways. So it can execute before the execution of the method and after execution of the method. And what you can do in between is you can play around with the execution of the method. What exactly do I mean by play around? Well, we'll have a look now. So like we had the join point, which used to hold a few information with respect to the location and certain details regarding the information such as method signature arguments, etc. So proceeding join point is almost the same, and you can see that it is extending the join point. So what exactly is proceeding join point? Let's understand this. It is a specific type of join point, and it goes beyond providing information about the intercepted point. It also provides capability to control the execution of the target method. So what are those capabilities? Let's understand. So in this advice method that I have implemented, first thing is I printed this statement and then I captured the time. So till the time I did not call this particular part, everything from here to here has to be executed before the execution of this method. And once I call pjp.proceed, what it tells to the main method that now you are free to proceed with your execution. And once that is done, then we have the execution handle over here. And then from here to here, this thing is going to be executed in the after section of the method execution, this method execution. So let's see what all things pjp does provide. So pjp, one thing is proceed, other is you could provide different objects. So basically you could pass the arguments if those are needed by the method to run. Then we have a few getters and setters around the information. So essentially what it means is that using the proceeding join point, you could control the execution of the method. So to sum it up, this is the before part, and using this statement, we tell the method to proceed with its execution, and once it's done, this is the after part. So using the after part, we are executing whatever we wanted to in the after section of the method execution. So this is about the around advice. So you see, around is somewhat more powerful in a way that by using the around advice, you could execute some logic before the execution of a method as well as after the execution of a method. So now let's go to the runner class, run this example and see its outcome. Great. So here is what we are seeing. So for cook food, method execution started, time elapsed to 0 millisecond. For the cook food, method execution finished. And now for the serve food, method execution started, time elapsed is 0 millisecond, and for the serve food method execution failed, and the similar thing for the generate bill and method execution finished. So that shall be all for the demonstration of the different advices, that is before, after and around. I hope that by now you would have developed a decent idea, a fair idea about the different details of the aspect oriented programming using the Spring framework. Please note that the details with respect to the different kind of point cut designators were not exhaustive, and of course there are much more patterns using which you could generate the regular expressions, but all that I taught in this video should be more than enough for the most of the coding that you will be doing with the Spring framework. But still, if you want to get more details around the concept of aspect oriented programming, I would suggest you to visit the official documentation of the Spring framework. That should serve as a reference document for all of your queries related to aspect oriented programming with the Spring framework. Having said that, if you have any questions or queries regarding the concept of aspect oriented programming in Spring framework, let me know in the comment section and I will try my best to answer all of your queries. So that shall be it for this tutorial. I hope you learned a thing or two from this video. So if you did, please make sure to subscribe to our channel and like this video. Thanks for watching. Thanks for sticking with me till last. If you haven't yet, please subscribe to my channel. I hope this video added some value. If so, please hit that like button and share with your friends. Your honest feedback in the comments is valuable to me. I regularly post informative videos on software engineering and computer science. Don't forget to hit the bell for instant updates. Take care and stay awesome.